This lesson is going to be just a quick review of simple compound and continuous interest. So just recall simple versus compound interest. A treasury note is an example of simple interest, and you can buy notes with 2, 3, 5, 7, or 10-year terms. A treasury note is purchased at 2% interest for $1,000. If it is a 2-year note, what would the payments look like? So at time 0, you purchase the note, put your $1,000 in, and then after 6 months, how much money do you get? Well, you're going to $1,000 times, and the interest rate is 0.02, but it's 6 months, it's half a year. So we divide it by 2 to get half the interest in half a year. So that's 1,000 times 0.01, or $10. Not the best rate right now. So $10 is what you get. And the way T-notes work is they drop that right into your bank account. They actually deposit $10, kind of like paying rent on your money, different than a bond. And after a year, you'll get another. Those 6 more months pass, so you'll get your half of 2%. You'll get another $10. And after 18 months, that's another 6 months, so $10. And then at 2 years, you get $10 for the last 6 months, plus you get your principal back. So all in all, that would be $1,040. $1,000 your original amount, plus over time you got $10. And it's like paying rent on money. Now, a bond's a little different. This is a bond or a note. This is where you'll put your money in, and it'll gather, like build a big nut over time, and then at the end of the time you get all of the money in a lump sum. So on day 1, if you bought a bond for let's say $1,000, you'd put your whoever's paying you on it, if it's a bond that a bank like a CD or something is paying you, after the first day you could look at it. After a day passed, you'd have your $1,000 still there, plus you'd get your 2% rate, and it's compounded daily, so you'd get 1/365th of 2% times 1,000 times the money that was sitting in there for that day. And then on the next day, at the end of day 2, the bank would owe you your original 1,000, plus they'd owe you the interest from day 1, plus they'd owe you interest on the money that was sitting in there for day 2. And on it goes. If you work a little algebra on that, that's the subject of another class, you end up with this little formula where A is the amount at the end, P's principal, N is the number of compounds per year. So for 365 for daily compounded, it would be 12 for monthly. That should sound familiar. If it was annual interest, N would be 1. T is the number of years. So a 2% bond, let's run one, for $1,000 for 2 years compounded daily would yield, well, A is, let's see if I got room to identify the things. No, we're just going to fill it in. So the P, the principal, is 1,000. 1 plus, and the rate is 2%, so 0.02. And it's compounded daily, so N is 365. To the N, 365 times 2 years. That's this formula right here. I'm plugging in. So then what I do is write that 1,000. I'm going to try to leave as much in the calculator as I can. First of all, I take the 0.02, I divide it by 365, and get a very small number. Then I add 1 to it, and it gives me, let's see here, 1.000054, and more numbers. And then 365 times 2 is 730. So what I'm going to do is, leaving all of this in the calculator, I raise it to the 730 power using either have this button or the y to the x button, or it might be x to the y button, just depending on which calculator. So raise that to the power, and we get 1.0408096 and more stuff. 1,000 just moves that decimal over 3 spots, so 1040, that's 3 spots. 0.80, I'll go ahead and round up to 81. So that compounding over simple interest gave us 81 extra cents. All right. So worth it, right? But also you can have, that was daily compounding. You can compound even more often, and you can go to infinite compounding, which may not make perfect sense in the financial, but it is used for scientific problems. If you've got bacteria or radioactive decay, those are thought to increase or decrease in the continuously compounding sense. So here we have a much simpler equation, and we often use this. If you took 1324, we use this equation to estimate the compounding equation if we're not sure what the compounding is. Maybe you don't know. I seem to recall my house interest is at 6.5% or something, but I can't remember if it's daily or monthly. Well, they're not going to be that far off between those two. So let's look at our example again. 2%, 2 years, $1,000, but nobody told us the compounding. Let's estimate it with this continuous formula and see how far off we are. So $1,000 e to the 0.02, and t is 2 for years. So it's 1,000 times e to the 0.04, which is 1,000 times. Then I'll raise e to that power. On your calculator, you should have like a little e to the x button. It's usually near the ln button. So e to the 0.04, 1.04. See here, I'll just write it in here. 0.04081. Oh, that's enough. So 1,000 will move that over. 1040.81. So you can see that's a pretty good estimate, at least for 2 years, of our example from the compounding case from the last problem. It's a lot easier to calculate. And then you just might want to be careful if we did 2 years at 3% and you use the compounded formula for a big number like $1 trillion. The U.S. debt that China owns is actually probably closer to $2 trillion now, but here's how much you'd get with the actual formula. But then with the continuous formula we used to estimate, it would be that. And they look really good. These first 4 digits are good. But if you subtract these two numbers, you'll find that there's quite a few zeros left. In fact, we're talking about $250 million, which is a good-sized government program. And so let's just make sure we can do a few things with the calculator with real numbers, because often you only see these integers in problems in courses that aren't applications related, and we are applications. So let's try this. 2x equals 4. I'm thinking of a number. When you multiply it by 2, you get 4. The number's 2. So you should say, oh, how did you do that? And I say, well, I divided both sides by 2, and I got x is 2. It's the opposite of multiplying by 2 is dividing by 2. But similarly here, you could divide both sides by 1.21. And on the left side, you just have 1 and 1, so x. And on the right side, we just get to use the calculator on that and make sure you can do a couple things on the calculator. 18.695 divided by 1.21. I get 15.45. And there's a sort of a question like, how do you know how many digits? And generally, it's one more digit than your last number. So typically, if you had 3 digits here, you would have 3 or 4 digits, typically 4 in your answer. But this is just kind of ridiculous. So I'm just doing 2 because I'm having a financial focus on this, and that's pennies. So we'll just go with that for now. It shouldn't scare you if the x is on the right side. Again, this is 1.32 times x. So we just want to divide it by 1.32. And that means you have to do the same on both sides of an equation. So you just do those two numbers divided by each other. 16.43 divided by 1.32. Make sure you can do that on your calculator. And I get 12.45 roughly. And then here's another linear. In this case, we have the x term we're interested in, but there's this other trash over here. So we'll first get the x stuff by itself. And so on the left side, we have, looks like 21.44, and on the right side, 1.32x, because those two cancel. So we know that x is, divide both sides by 1.32, 21.44 divided by, so there you go. And just a quick review. Hopefully this is pretty fresh in your memory from a previous course, or you haven't lost much on it. You should definitely be able to do any of these with no trouble in this course. So then on the next page here, we have a little more evaluation. And 2 to the third power, just remember, 2 to the third power means you have 2 times itself 3 times. So 2 times 2 is 4. From that, 4 times the 2 is 8. So you can only multiply 2 things at a time. And 3 to the 1.25 is kind of hard to figure, so we use you'll either have this button or this button on your calculator. And you just enter 3 to the 1.25 power. And it's like 3.948. And E, you may know what E is, but you can also use the E to the power button. So that's E to the X or blank on your calculator. Let's try 1 and see if we get the right value for E. 2.718. And I will use at least that much precision for E in this course. And E to the 3.4, let's just make sure we got that one down. That's 29.964. And E to the 0.073, that's just a little arrow. .076 rounding. All right. So then something you might remember from the old days is if you had something like x squared is 4, then to solve that you take the square root of both sides, because the square root's the inverse operation, or the inverse operation of squaring. So you get 2, and then, oh yeah, we have 2 plus or minus. Well, the inverse operation of e to the power is this ln, or called the natural logarithm. So if you have e to the x equals 5, instead of square rooting both sides, you natural log both sides. And then on this side, what you want to happen happens. And then ln 5, you can do on your calculator. Take the natural log of 5. It's the ln button, not the log button. And I get 1.609. So you can go back and check just by doing e to that power and see if it's close to 5. And also remember ln is the same as log base e. It's a short way to write it, and your calculator usually has an ln button on it, which is near the e to the x button. So here's another one. You've got the x's up in the what I call the attic, or the exponents of e here. So we want to get that x out of the exponent. So we'll take the natural log of both sides. I have to do it to both sides. So on this side we get 2x, and over here we get natural log of 8.4. I'll just take another step and go ahead and do that natural log of 8.4 in the calculator. 2.128. And then divide both sides by 2. And we get x is 1.064, I believe. All right, and you can plug that back in. You can say, oh, e to the 2 times 1.064. What's that? On the calculator, just do 1.064 times 2, and then e to the power, and I get 8.398. Is that close enough? 8.4? Yeah, sure. That's the end of the lesson.